I'd like to just start by welcoming you all, wherever you are in the world. Good morning, afternoon, evening, or if you're in Australia, good night. My name is Doug Evans. I'm the director of the International Institute for Environmental Studies. And if you have never joined us for one of our lecture series, welcome. Just let me take a couple of minutes to start and say a few words about the Institute before I introduce our series coordinators and our speaker. The International Institute for Environmental Studies is a group of around 20 universities in Europe, North America, and Asia that have joined together to try to develop a better platform for collaboration and integration of environmental research, both policy and science. And we have a number of different activities that we run each year. And so even if you're from an institution that is not one of our member institutions, you're more than welcome to join us for any of our activities like these lecture series or our various annual meetings. For graduate students, we have an annual graduate forum that's held in the fall. You can watch our website, which is shown on the slide on the screen right now, for details of those various activities. And we would be really pleased to have you join us at any of the activities that we organize. So welcome to this, the first in our lecture series on air pollution and human health. And I want to start by thanking the organizers of this series, Dr. Shaowen Zhong from Sun Yat-sen University in Guangzhou, China, and Dr. Hui Dan from Trent University, who have done a great job in pulling together a really interesting series of lecturers. And if our past experience is any indication, I think you will find that each of the lectures is really quite interesting and provides a really good overview of some of the top people in the world in this field. So thank you both Shaowen and Hui for all your efforts in putting this together. Dr. Zhong is going to be the normal host for these lectures, and she'll be here each week to introduce the speaker, but I'm going to introduce the speaker today. And we've had a little bit of a change of plans. Professor Dharmage was intending to speak today, but she is caught in transit and with a plane schedule that she won't get back in time to actually do the lecture. So Dr. Gayan Bowatte is going to do the lecture for her. He is I can just see a second here. There we go. So just a bit about Professor Dharmage. She's the head of the Allergy and Lung Unit at the Melbourne School of Population Health. Did her master's degree and MD in University of Colombo in Sri Lanka, and then a PhD at Monash University in Australia. And as you can see, she has quite an extensive record of publications and citations. And her background is in epidemiology, respiratory medicine, and allergy interactions of allergens with human health. Dr. Bowatte is a postdoctoral research fellow who works with Dr. Dharmage, and he's also in the Allergy and Lung Health Unit at Melbourne School of Population and Global Health. Did his undergraduate at the University of Peradeniya, and then a PhD at Melbourne University. And you can see that although he's just at the start of his career, he obviously has quite an extensive number of publications and citations. And similar to Dr. Dharma, Dr. Bowatte does research on epidemiology and public health and environmental air quality interactions. So with that, I would like to thank our speakers for today. And I will now stop sharing my screen and turn it over to Dr. Bowatte.
Thanks, Chuck, for the nice introduction today. So this is an introductory lecture to air pollution and human health. As Chuck said earlier, so this lecture was intended to do by Professor Shyamali Dharmage, but unfortunately she cannot make it today, so I'm going to replace her. So in this lecture, air pollution and human health, I'm going to briefly talk about the effects of air pollution on human health. So in this lecture, so I will be talking about a brief introduction to air pollution and health. Then I'm going to talk about classical examples of air pollution and human health using two well-known studies. Then I'm going to talk about mortality and morbidity of indoor and outdoor air pollution. Then short and long-term air pollution exposure and human health. Then I'm going to finish up with the summary. When you talk about pollution, it is not about air pollution. So there are water pollution and soil pollution as well. So this is the largest environmental cause of disease and premature death in the world today. So when you talk pollution, that is the largest environmental cause of diseases and premature death. So this pollution caused the disease caused by pollution were responsible for about estimated 9 million premature deaths in 2015. So when you talk about these percentages, it's about 16% of all deaths worldwide. So in other words, the environmental pollution accounted for 16% of all the deaths worldwide. So when you talk about air pollution alone, it caused about 7 million deaths worldwide in 2015. So it is about 78% of the deaths from all pollution. So this is a very big number. So the air pollution by itself has a large amount of effects on human health. When it comes to air pollution, anthropogenic activities have increased the air pollution levels, and this leads to adverse impacts on human health and also in the environmental health as well. So air pollution is a global issue. It is not localized. So airborne pollutants, they can travel across to very far distances. They can cross national boundaries and they can cross continents and oceans. So when you think about air pollution, so we can be kind of like confident that if we apply air pollution control methods in our local settings, and we can see that we are healthy because we are not going to expose to high level of air pollution. But that is not the case because these air pollutants, they can travel very long distances. So if our neighbors are going to pollute their atmosphere by not applying any pollution control methods, so this can directly affect our airships or local settings. So I will talk about main air pollutants. So there are a number of main air pollutants that mainly investigated in terms of health effects. So one of the widely studied air pollutant is particulate matter, known as PM. So it is a mix of solid and liquid droplets arising mainly from fuel combustion and road traffic. And then, so these are tiny particles. So these particles can go deep into our lungs, and they can cause different diseases. And nitrogen dioxide, which is a gas mainly emitted from road traffic or from indoor sources like gas cookers. And sulfur dioxide, again, it is a gas. It can be emitted from burning fossil fuels like coal. And ozone at ground level, we know that ozone is good when it has in the correct place in the top of the atmosphere. When it's come to the ground level, it's harmful. It can cause major health effects to human. So I will talk a little bit about particulate matter, because this is one of the most widely studied air pollutant. So this particulate matter, so these are tiny particles, as I said earlier. These are very tiny, and so these tiny particles can can be respirable, and some of these particles can be trapped by the respiratory tract, and some of them can go deeply into the lungs. So when you're talking about the sizes, so this the gray color rod represents a human hair, which has the thickness of about 50 to 70 micrometer in diameter. And these brown color particles, they are fine beach sands, about 90 micrometer in diameter. And the small blue color balls, they are the PM10, or particulate matter less than 10 micrometer in diameter. So these particles can also can cause human health effects, this PM10. So this represents dust, pollen, mold, etc. And the red color, tiny balls, represents PM2.5, or a particulate matter less than 2.5 micrometer in diameter. So these are very tiny. So this can go deep into our lungs to our alveoli, and there are evidences to show that these tiny particles can go to our bloodstream as well, and causing numerous diseases. So these can be emitted through a number of anthropogenic and natural causes. The anthropogenic causes to emit these particulate matter are mainly fuel combustion, like coal in power plants, vehicle emissions, like that. So when you talk about air pollution and human health, exposure to air pollutants can affect human health in various ways. So this can cause mortality, and this can increase the morbidity of the people. As I said earlier, air pollution is a global health issue. So the air pollution is hard to escape. So no matter how rich you are, how educated you are, how good area that you are living, it is all around us. So air pollution is a global health issue. So someone can say that we can't see any visible smog. So our sky is very clear, and we are having a very good, very clean, clean atmosphere, very clean, or good air quality in our surrounding. But it is not the case. Even though the sky or the atmosphere is very clean, but it's not a good indicator of good quality air that you have around you. So even though the air is very clear, but the air pollution levels around you is very high. So because the air pollution is invisible. So I'm going to take two classical examples of air pollution and help to show how people have started to work in the air pollution epidemiology work. So one of the most widely known study, or the widely known phenomenon happened is the Great London Smog that happened in 1952. So these incidents exceeded. This incident had like 12,000 excess deaths in London in 1952 to 1953. 1952, sorry, December 1952 to February 1953. So what happened in London in 1952 December is a unique incident. So Londoners, they were using cheap coal for their cooking purposes and their heating purposes, and the pollutants, they were trapped in London because of a unique atmospheric condition, and air was not circulating for like 5 days, and air was trapped, and the pollution levels were very high. So because of these very high air pollution levels, the mortality tend to increase. In this graph, you can see that. So this was later studied by Bell and Davis in 2001, and they have shown that so normally in London, the normal weekly mortality rate is about 2,000, but when these incidents happened, raised more than 4,000 deaths per week. And this condition were there, like these conditions were there like up to the February 1953. So this is like a 2 months period. So the incidence was happened in December 1952, but the effects of this incident continued to happen until February 1953. So they have estimated that about total 12,000 excess deaths were associated with this high air pollution incidents that happened in London in 1952 December. So the second study that I'm going to check is the Harvard six cities study. This is again a very popular, very famous study in air pollution epidemiology. So people were not believing that air pollution is causing health effects until these studies conducted. So Dockery and the colleagues in 1993, they have published this wonderful study to show that air pollution is directly associated with mortality rates in the cities of the United States. So what you can see here in this graph, this axis shows the fine particles in microgram per cubic meter, and the death rates shows in this axis. And you can see that these letters, so these represents different cities. You can clearly see that there's a positive, positive linear association between fine particulate matter concentration and then death ratio. So the highest polluted cities, they have the higher death rate, and the lower polluted cities, they have the lowest death rate. So this clearly showed that the air pollution is directly associated with mortality. So people were, as I said earlier, people were reluctant to believe that air pollution is causing adverse health effects, because at that time, smoking was the most dominantly studied environmental exposure. So people believe that not air pollution, but smoking is causing these health effects. But in this study, so these researchers, they were able to control for individual risk factors like smoking, education, and body mass index. So after adjusting for these risk factors, so they have shown that still there's a very clear association between increased air pollution and death rates in different polluted cities in the United States. So these studies feed into the air pollution literature to show that there are effects, adverse health effects of air pollution, adverse effects of air pollution on human health. When talking about air pollution, so we need to understand that air pollution can be happen inside our houses or our buildings, or it can be happen outdoor or in the outer environment. So when we talk about outdoor environment, outdoor air pollution, or the ambient air pollution, so this can be caused by traffic-related air pollution, or from the power generation and the coal power plants or diesel power plants. So this is the outdoor air pollution. So when we talk about household air pollution, it is the pollution that happen inside the buildings. So this can be happened, or this can be occurred because of generation of pollutants from combustion of fuels, like when we're cooking using LPG gas. In less developed countries, they use coal, wood, or kerosene for cooking. So these unclean type of fuel can generate high level of air pollution inside their houses. So it is true that indoor and outdoor air pollutions are different. The location of the occurrence of air pollution is different, but the air pollution can contribute to each other because the air can move from one place to the another. So when you're talking about indoor air pollution, when the indoor air pollution is high, the fraction of this indoor air pollution can contribute to the outdoor air pollution as well, and this can happen vice versa. So this very nice study was done continuously from 1990 to 2015. So that's a global burden of disease study. So this study, the aim of this study is to estimate the risk factors and deaths associated with these risk factors. So air pollution is also one of the risk factors that they have considered in their study. In 2015 study, so they have showed that there are about 7 million deaths linked with air pollution. So on these 7 million deaths, 2.9 million deaths from indoor air pollution exposure, and 4.2 million deaths were from outdoor air pollution exposure. So this is very huge, like talking about this number of deaths associated with air pollution. So it is significant. We can see that the air pollution is significantly associated with human health. Talking about household air pollution, as I said earlier, about 20.9 million people were killed by air pollution in 2015. And about more than 99% of these deaths due to household air pollution occurred in low and middle income countries. In this picture, you can see that on the left-hand side picture, this women, they're carrying dried cow dung cakes for cooking. So this use of biomass fuel to mainly for cooking purposes. So, and on the other picture, on the right-hand side, you can see a woman using firewood for cooking, and two kids are there. So you can see that the level of air pollution might be because they are directly inhaling the air pollutants emitting from these unclean fuel types. Outdoor air pollution is one of the major environmental health problems, regardless of where you live, like whether you are living in low, middle, or high income country, so the outdoor air pollution affects you. Again, like in indoor air pollution in 2015 global burden of disease study, they have found that about 90% of these deaths due to outdoor air pollution also occur in low and middle income countries. So this is very interesting because the major fraction of air pollution related diseases or the deaths, they occur in low and middle income countries because their economies are not that strong to support strong interventions to reduce air pollution, like to provide cleaner fuel for cooking and lighting purposes and for rural population. And there are not enough air pollution monitoring networks to monitor and regulate the air quality in the urban airsheds or to control the air pollution in these countries. And they don't have enough funds to pump to control, like to provide good quality public transport system. So if they can do this, they could be able to reduce this air pollution and reduce the risk of getting diseases and this attributable risk for deaths. So this air pollution, as I said, air pollution related deaths mainly occur in low and middle income countries. In this graph, you can see that so the deaths happened in 2015 of pollution. Different pollution sources are contributed. In purple color, that's soil, chemical, and metal. Green color, occupation. Orange color, water, and blue, air. You can see the blue color is dominated in these bars, which indicates that in low income countries, air pollution is the highest contributor for the deaths. And also in lower middle income level countries, upper middle income level countries, and even in the high level income countries. So the air pollution is the major contributor for the deaths due to pollution in 2015, according to the Global Burden of Disease study. As I said, the Global Burden of Disease study started in 1990 and continued up to 2015. So this shows that from 1990 to 2015, that the deaths attributable to PM2.5 is gradually increasing up to 2015, from 1990 to 2015, and the contribution of different cause of death to the deaths attributed to PM2.5 is different. In different colors, you can in these bars, you can see the representation of different cause of death. The blue color indicates tracheal, bronchial, and lung cancer, and the I think it's orange. Orange color indicates ischemic heart diseases, and the gray color say intravascular diseases, followed by lower respiratory lung. Chronic obstructive pulmonary diseases in yellow color, and the purple color is lower respiratory infection. So you can see that the majority of the deaths attributable to PM2.5 is coming from cardiovascular and respiratory diseases. So this is a nice visual representation of how air pollution can attributable to annual deaths from, so this is mainly PM2.5. So you can see that in two cities, the top one is Dhaka in Bangladesh, and the lower one is Sydney in Australia, have two different levels of air pollution. So here you can see that in Dhaka, Bangladesh, it's about 5.7 times higher than the WHO standard. The WHO standard or the guideline for PM2.5 is 10 micrometer per cubic, 10 microgram per cubic meter annual average. So in Bangladesh, it's 5.7 times higher. But in Sydney, so it's 8 microgram per cubic meter per year. So it's like 20% lower than the WHO standard. But when you talk about the annual deaths attributable to this air pollution exposure, in Bangladesh, Dhaka, it's very high, over 150,000. But in Australia, even though the air pollution levels are very low, but their contribution to the annual deaths from PM2.5. So, as I said earlier, so PM2.5, or the particulate matter less than 2.5 micrometer in diameter, is one of the best studied form of air pollution and is linked to a wide range of diseases. As shown in the global burden of disease results, the strongest causal associations are seen between PM2.5, cardiovascular, and pulmonary diseases. So studies, they have shown that specific causal associations established between PM2.5 pollution and myocardial infarction, hypertension, congestive heart failure, and also cardiovascular mortality. So there are strong evidence to show that PM2.5 is associated with these cardiovascular outcomes. And also, causal associations have been also established between PM2.5 pollution and chronic obstructive pulmonary disease, or COPD, and also with lung cancer. So most importantly, the International Agency for Research on Cancer has reported that the airborne particulate matter, including PM2.5, and also the complex ambient air pollution mixture, are proven type 1 human carcinogen. So those are the kind of like the previous slide showed the established causal associations of particulate matter air pollution exposure and the disease outcomes. So this slide shows the emerging evidence that showing there might be a causal association between PM2.5 and these disease outcomes. So in children, there are emerging evidence to show that PM2.5 is associated with diabetes, decreased cognitive function, hyperactive disorder, and also autism. Also in adults, there are evidence to show that PM2.5 is associated with diabetes and also in dementia. There are emerging evidence to show that air pollution exposure, or the PM2.5 exposure in this case, is linked with premature births and also low birth weight. So when you talk about air pollution exposure, it's important to understand short and long-term air pollution exposures and human health, because we take our daily activity or our annual activities, so we are exposed to different level of air pollution. sometimes when we are walking close to a busy road, so we expose to very high levels of air pollution. And when we live in a kind of, if someone is living in a living closer to a busy road, this particular person is exposed to very high level of air pollution for a very long period of time. So, but in contrast, someone may live in a house that the air pollution level is very low. So the level of exposure is very different. So we need to understand what are the associations and what are the associations between this different level of air pollution exposure when considering the short and long-term exposures. So when considering short-term exposures, time series and case crossover studies are used to evaluate this association, short-term associations between air pollution exposure and health outcomes. When it comes to long-term exposures, cohort studies with multiple follow-ups, so long-term follow-ups are the best study designed to understand health effects of long-term air pollution exposure and health outcomes. So I'm not going to go into deep, but I'm going to give you a couple of examples of short-term air pollution exposure and health to show that that air pollution, short-term air pollution exposure is linked with adverse health outcomes. A recent recent review showed that short-term elevation of particulate matter less than 2.5 micrometer in diameter increased the relative risk of acute cardiovascular events from 1 to 3% within few days. So this is short-term exposure. Another example, a systematic review published in 2015 showed that short-term exposure to PM10, PM2.5, nitrogen dioxide, and also ozone associated with increased risk of asthma-related emergency room visits and also hospitalization. So these are the two examples to show that short-term air pollution exposure is associated with adverse human health outcomes. So it is important to know that sometimes the exposure right away may not give the disease outcome. It might take a little bit of time. So these studies have shown that exposure within a 1 day may not give the outcome, but it may take a couple of days. We call it the lag effect. So there is a kind of a period between the exposure and the disease outcome. When it comes to long-term air pollution exposure, we talked about that short-term air pollution exposure is about 1 to 3% when it comes to cardiovascular diseases. But when we talk about long-term exposure, over several years, this increased the risk of cardiovascular diseases by a larger magnitude. Like talk about 1 to 3% exposure in short-term exposure. But when it comes to long-term exposures over several years, the magnitude of the risk of cardiovascular diseases related to PM2.5 exposure might be 10%. So another example is that this is coming from one of our own studies. We have shown that early childhood air pollution exposure, like nitrogen dioxide, PM2.5, and black carbon. Black carbon is also a component of PM2.5 associated with incidence of asthma in childhood and also in adolescence. So in this study, we have shown that the early childhood exposure or the exposure during the first year of life is associated with asthma outcomes in late childhood as well. Not only that, the exposure during the childhood is also associated with high level of incidence of asthma in childhood and also in the adolescence as well. The air pollution is disproportionately associated with human health in different groups of people. So because the air pollution levels are different in different countries and different communities, and there are other factors contributed to this disproportionate association. It is known that poor and the vulnerable people, they are more affected by air pollution. As I said earlier, majority of these air pollution related health outcomes, or for example, deaths occur in low and middle income countries. It is known that children and also elderly people, they are in high risk of getting diseases because of air pollution exposure. When we talk about children, studies have shown that extremely low dose exposure to these air pollutants like PM2.5 or nitrogen dioxide in specific window periods may have higher risk compared to the exposures beyond these windows of vulnerability. When we're talking about the windows of vulnerability, in utero exposure and early infancy exposure is very important. So these exposures can cause disease, disability, and death in childhood. And also, not only that, so these exposures during these vulnerable periods, these can be, the effects of these exposures can affect the health of an individual for a very long period of time. So it is not the exposure at that point is important, but the health of the exposure at that particular vulnerability window is affecting the overall health of a person for a very long period of time. As I said earlier, elderly and also the people who are at risk of getting diseases, like the people who already have COPD or cardiovascular diseases, they have an excess risk of air pollution exposure. There are some people with some genetic mutations, so these people are also in high risk of exposure to air pollution and getting diseases. For example, some of our studies have shown that there are people, they don't have a particular gene to code a protein to produce an enzyme, which is contributed to detoxify some of the pollutants. So some people, they don't have this particular enzyme to detoxify air pollutants because of their genetic mutation. So these people, they are in higher risk of getting diseases because of air pollution. So air pollution is disproportionately associated with health in different groups of people. So those are the health effects of air pollution. So as I said earlier, so I'm not going into detail. So this is the introductory lecture for air pollution exposure and human health. So I'm looking at the overall overall associations of air pollution exposure and human health. So this is very interesting. So these interesting two studies showed that under a business as usual scenario, so if we are not going to do any great or aggressively not going to control air pollution, it has been projected that more than 50% increase in mortality related to ambient air pollution will occur in 2050. So that is 4 million deaths occur in 2050, increase of 6.6 million deaths in 2050. So this is very high. So this is the prediction that they have made based on that we are not going to make any big changes to the current level of air pollution. However, if we are going to reduce PM2.5 pollution by applying aggressive control methods, it has been projected that this the current or the 4.2 million deaths in 2015 could be reduced by 23%. So this happens only if we are going to apply methods to aggressively apply methods to control air pollution. So this is very important to know that, so because the air pollution is a modifiable risk factor, so we can control it. So because we are the human, the main contributor for air pollution. So if we can apply control methods, so we can reduce the effects of air pollution on human health as well. Talking about the air pollution thresholds and health effects. So the WHO has introduced thresholds or the guidelines to control air pollution, and different countries, they have adopted different air pollution guidelines or thresholds to control air pollution. So these thresholds or the guidelines are only for regulatory purposes. So so far today, there are no evidence of a threshold of air pollution exposure and human health. So recent epidemiological studies have shown that when you're talking about PM2.5, has health effects at even below the WHO standards. So basically speaking, that air pollution, if we can reduce air pollution level to a very low level, still we can get health benefits out of that. So any reduction in exposure will produce benefit. So in this graph, you can show that the acute PM2.5 exposure and mortality. In high levels, the air pollution, the relative risk of increased mortality is kind of getting stable at the high level of air pollution, but in low levels of air pollution, it is increasing. So if we can apply methods to control this low level of air pollution, the benefit is higher, because you can see that the angle of this line is high compared to, so the angle is lower compared to the when it's going to be higher levels of exposure. So if we can apply methods to control even very low levels of air pollution in the air. So we talk about air pollution, we talk about climate change, and we talk about health effects. So air pollution and climate change, they are interlinked. Some pollutants, they are directly linked with the climate change. And air pollution, we know that air pollution is causing adverse health effects in human. And also we know that climate change is also causing health effects in human. So if you can control air pollution, then indirectly or directly, we can control climate change as well. So if we control, or we can apply methods to control air pollution, then we can reduce the amount of deaths or the health effects caused by climate change as well. So this is a win-win situation. So if we can control climate change, we can control air pollution, and it can reduce the climate change, and we have a lot of benefits from controlling air pollution as well as reducing the climate change as well. So that comes to an end of my short lecture today. So before wrapping up the lecture, so I would like to summarize the major points of today's lecture. So air pollution is the #1 environmental pollutant that causes mortality and morbidity in human. And there are solid evidence to show that air pollution is associated with adverse health outcomes in human. And also, air pollution is disproportionately linked with diseases. Some group of people, they are in high risk compared to the others. Also, causal associations between air pollution and cardiovascular and pulmonary mortality and morbidity are established. And there are also emerging evidence with some of the non-communicable diseases and air pollution exposure as well. So that brings to the end of the lecture, and thank you so much.
Okay, thank you very much, Dr. Bowatte, for an excellent introduction to this series. I'm sure that there are some questions from people out there, so at this time, please feel free to either put your mic on and ask a question, or to simply type it into the chat, the group chat function.
Hello. Hello. Can you hear me?
Yes, I can hear you.
Okay, so thank you very much for the nice presentation in the lecture. I am new to this field, so it was quite beneficial for me to understand the air pollution. I'm working on climate change and health as a doctoral researcher in the University of Eastern Finland. I have a question related to the air pollution, climate change, and health. So first of all, I have two questions. You told about the ambient air pollution. So I wanted to know, this is the kind of outdoor air pollution. So is there any other sort of terminologies used for outdoor air pollution or any other types of air pollution as well, except ambient air pollution? And my second question is that this air pollution, it is linked to the climate change and ultimately the health, for example, hospital admissions. So does this air pollution affects more to lower the temperature, or it is affecting more for heating up the temperature? For example, you know, is it related more to the heat waves or cold spells? So
Yes.
yeah.
Yeah, yeah. So it's a very interesting question. Yeah. So your first on the ambient or the outdoor air pollution. Not sure about whether there are any other terminology for that. Not sure whether, yeah, not sure about that. So those are the two words that are the most commonly used, ambient and the outdoor air pollution. And then talking about air pollution and climate change. So your question is about whether the air pollution is linked with the increased temperature and health and decreased temperature and health. So did I get it correctly? Yeah.
Yeah, my question specifically is that, for example, if you look out at the literature, there are two sorts of studies. For example, if climate change and hospital admission, some studies have specifically looked at the heat waves, and some have looked at the cold spells. So I wanted to know, does the air pollution has more effect on the heat waves? Does it increase the heat waves, or does it have more effect on the cold spells? Like what sort of effect it has on the climate change?
Yeah, it depends on the pollutants that you're thinking of. Like if you're talking about the PM 2.4 particulate matter air pollution, so that there might be differential effects on the atmospheric heat. So because I'm not an expert in this area to talk about air pollution and climate change, because I just giving some examples of that. Air pollution can reduce climate change, and in that case, both air pollution related and climate change related diseases can be reduced. But I think from my knowledge that um, the pollutants can cause, sometimes it may cause low levels of temperatures. It may cause high level of temperatures depending on the climatic conditions and different pollutant types, and uh, that may related with different health outcomes, both increased temperature and decreased temperatures. This might not giving you the direct answer to a question, but yes, so because I'm not an expert in climate change, but my work is mainly in air pollution.
Yeah, I think I know somehow now, but thank you very much. It was a very nice introduction to the air pollution. Thank you.
I see that we have a question in the chat there from Kinjal. I have a quick question. What does occupation mean in the slide that shows 92% deaths in lower middle income countries?
Yeah, so do you want to know about so this one? Probably this one. Yeah, so when the Global Burden of Disease project, this Global Burden of Disease project, so they looked at the pollutants and mortality. So they have included air pollution as a separate one, water pollution as separate one, occupation-related air pollution into a separate one. Sorry, occupation-related pollution into a separate one, and soil, chemical, and metal related pollution into a separate one. So that's why. So there are 4 different types of pollution. So this, by combining this all 4 elements together, so they call pollution. Not sure whether I have correctly answered your question.
So I think the question is around the green bar, the occupation. I assume that means occupational exposure?
Yes, that's occupational exposure.
Okay, so something that they would get exposure during their work.
Yeah.
And I see this question from Lynn. There have been many research studies on the health effects of PM 2.5. So could you give some suggestions about the next research direction?
Yeah, so there are a lot of research have been done on PM 2.5 and health effects. So the recent work is mainly on air pollution, PM 2.5 exposure, and metabolic diseases. Probably people are looking at air pollution exposure or the PM 2.5 exposure and diabetes, obesity, those kind of outcomes, and also the neurological diseases like dementia. So those are the recent advances looking at PM 2.5 exposure and the health outcomes. But there have been lot have been done, but people are still doing research to link this PM 2.5 and number of other diseases.
And I think I'll defer to Professor Zung on this one, but I think as we go on in the lecture series that we'll have some talks that will elucidate that the answer to that question much more clearly.
Okay.
I have a question about the graph that mentioned any reduction to exposure will produce benefit. And I think what that's implying is a small change will help, but it will help those who already are the least susceptible. And I'm understanding that it would take large-scale systemic change to help those who are really affected by it. Am I following that correctly?
Yeah.
Okay. So while you say any reduction exposure will produce benefit, it won't produce benefit for those who are truly the most affected by it.
Yeah, it depends. Like, so if you're talking about general population, like for example in Australia, so we have very low levels of air pollution levels. But even if we can reduce that level to a couple of microgram per cubic meters below that level, still. We're getting significant health benefits, because it's not only the susceptible people, but we are thinking about when the overall population exposed to this level of air pollution exposure as well. So it's not only the susceptibles, but in the overall population as well. But the susceptible people might have extra benefit of reducing this, reducing air pollution to further low levels.
Okay, thank you.
Well,
we have a question from,
yeah. Yes, thank you, Dr. Bowatte, for your amazing introductory lecture, and it brings us very clear frame and rich context on how harmful of the air pollution exposure on human health. Well, I have a quick question. Well, I know that the air pollution problem is the global issue, and governments are making efforts to control the air pollution level to meet the air quality standard. But for the general public, I mean, the ordinary people, is there any effective action they can do to minimize the harmful effect of air pollution?
Yeah, so thanks, Shogun. So your question is about like the governments, they are putting a lot of effort to reduce air pollution, but as individuals, what we can do. Yeah, so there are a lot of things to be done. So we're thinking about our contribution to air pollution. So think broadly, like, so what our contribution to air pollution? Think about, everyday activities, what we do, getting out of our home and go to work. So what kind of transportation we use? Do we use our own car to go to work? And, and if we use public transportation, or even we use a bicycle to go to work, and So this is kind of like thinking about us and thinking about what our contribution to the air pollution. So if we can think about our contribution to the air pollution, if we can change our behaviors, so that could greatly reduce the air pollution levels as a whole. So this is about when you're talking about not about the developed countries, when you're talking about the developing countries. So there are a lot of issues that the people can individually contribute to control their pollution levels. So people in the level, currently I'm living in Sri Lanka, like look at the situation, people, they burn their garbage, and so that produces a huge amount of air pollutants. So if you can apply some measures to not burn that air pollution and do recycling, or not avoiding burning those the unnecessary things, so that can reduce a huge amount of air pollution emissions to the atmosphere. So individual behavior is very important.
Right, thank you.
I think there are two questions on the chat that probably could go together. Kenny Lau wants to know what defines clean, pristine air. Is PM the only measure of air pollution? And Mahmood wants to know what is the latest emerging pollutants in air. Maybe you could handle those together.
So what is the latest? The last question is, what is the latest emerging air pollution pollutant? And what is the first one? Sorry. First question.
What defines clean, pristine air? Is particulate matter the only measure of air pollution?
No, the clean, pristine air is a very important, very tricky question. So pristine air. So it is air. When you talk about air pollution and air, so when there's a very low level of human contribution to the air pollution, so that could be defined as pristine air, but I'm not 100% sure about that. The pristine air is the lowest level of air pollutants that we can have. So you know that the normal constituents of atmosphere is nitrogen, oxygen, carbon dioxide. So there are different ratios, but so there are no clear definition for pristine air. So if we can have these components and very low contribution from the anthropogenic sources, that could be defined and pristine air. But we have to be careful. But so there are not only the anthropogenic causes causing the air pollution, the natural causes are also contributing to the air pollution as well. When you're talking about thinking about dust storms and volcanic eruptions, so these natural events contribute to air pollution in a big scale. So it's a kind of like a balance between the anthropogenic activities and natural causes. So it's very hard to define what pristine air is. And the other question is, PM 2.5, is it the only measurable air pollutants? No, there are a lot of measurable air pollutants. So I talked about mainly PM 2.5 because it is one of the most widely studied air pollutant. There are other common pollutants like nitrogen dioxide, ozone, carbon monoxide, and many other volatile organic compounds. So those can be measured. So the final question is about what is the most is it the leading most emerging air pollutant in the atmosphere? That's a little bit tricky. So the air pollutants are always there, but it depends on the local situation. So if you're living in a country like a developed country, like in Australia or the Canada, the pollutants, the contribution of the pollutants to the atmosphere is different. But if you're living in a country like Sri Lanka or India or in Bangladesh, their activities are different and their contributions are different. So the pollutants are different in different, the composition of the pollutants are different in different countries.
Okay, are there any other questions that people would like to ask? If not, let me thank our speaker today, Dr. Bowatte. That was a very interesting lecture and a great start to this series. I hope you'll all join us next week when Professor McLaren from York University is going to talk about the chemistry of air pollution, so getting into a little bit more detail on some of the topics that we heard about today. So thank you all for participating. We'll see you next week at the same time. And thank you again, Dr. Bowatte.
Yeah, thank you so much.